Okay, so this should be Pongsathorn, right? Okay, Cap, you're up.
Oh, okay, ครับ let me share my screen.
Hi, I'm Pongsathorn. My project is about creating a handmade model to predict LinkedIn post reception. For context, I saw my friends posting on LinkedIn quite often, so I wanted to do that too. With that, I then wondered word choices and some other parameters will affect the number of reactions a post will get. My goal is to identify factors that affect post reception, aka reaction count. I also wanted to try and create my own algorithm to build the model. I settled with gradient descent algorithm to generate a multiple linear regression model. I also explored the stochastic model, but more on that later. Here's the mind map. It shows the probabilistic and statistical methods I use as well as the skills that are dealt with during the course of the project. And here's the part for analysis, pipelines, and the related applications. The dataset I used is from Kaggle. It is a 90.4 megabyte CSV file with 34,000 rows and 19 columns. I did a quick cleaning to get a much better dataset with 32,000 rows and 12 columns. With the dataset prepared, I started extracting interesting independent variables from it. Some interesting ones are the ones I did for the text where I use NLTK's tokenizer and Python's word frac library to find the average word frequency of each body of text to kind of see how eloquent the authors are. I also did a one-hot encoding for the media type parameters, but it turns out they don't correlate well to the reception of the post, so I did not include them in the final set of independent variables, which brings me to how I explore the data and normalize them. Since the columns are initially skewed, I applied normalizing functions to either variables and they normally fit like so. Since, as I said, there were some irrelevant variables, so after I dropped those columns from the dataset, these are the final ones to be used for the training. Next, I did a scatter plot of each independent variables against the log of the reaction count and looked at the correlation coefficient of each linear regression. And as you can see, there are lots of fluctuations. I can reasonably speculate that this is due to the data points being from the real world, so there are bound to be lots of errors. Another observation is that HSP or hour span variable does not correlate well. I think this is due to sampling issues and maybe there are much better variables to use to account for time delay between posts being posted and when it is observed, among other things, variables that are beyond this project's scope. So here's the fun part. With a normalized function, I can use multiple linear regression to create a prediction model. The method I decided to use to generate the model is gradient descent with static learning rate. I actually implemented a stochastic version of GD, but I figured the dataset is too small, and randomizing points to adjust the slope vector would make the result less precise, and in turn less accurate. For the training model, I set the approach to be 15,000 steps and learning rate at 0.00001. This is the result. The training took an hour and 20 minutes. After running the model through the test set, the R-squared is 0.178. At first I panicked since it was a pretty low value, but I scoured the web and learned that R-squared of 0.2 is decent enough for real-world data. And that means my model can accurately predict the reaction count accurately 20% of the time, even with the highly volatile nature itself. So I'm feeling pretty good. I made this equation to encapsulate the model. I rounded the coefficients to make it easier to read on the basis that the smaller digits wouldn't significantly affect the prediction. I then tried using the model on a random post on LinkedIn. In this case, the first post on my LinkedIn feed by Mr. Paul Ark. He shared a video and put a little caption on the post. Luckily, he also has followers, which match the columns that are available in the dataset. With that, I feed the post information into the extraction function and the trained model's prediction method. The model predicted 14 reactions, while the actual post got 63 reactions. The difference was pretty disheartening, but given the low R-squared, I can see this happening quite often. This inaccuracy is also a great tie-in to talk about this project's limitation and some possible development that I propose. So this model is trained only with the dataset from Kaggle, where there are only tens of thousands of roles and the profiles are all with 500 connections with a positive follower count. Since on LinkedIn, there are also people whose accounts are not open for following, the dataset I use is definitely not representative of all LinkedIn posts. Some parameters from the dataset are also too limited, such as mentioned earlier, the HSP or outspan, or how LinkedIn displayed the duration and introduced huge intervals into an otherwise continuous data. And of course, the last thing, there are many, many more affecting parameters other than the one I investigated in this project that could have the potential to predict reaction count better than what I had. So some ideas for future development would be to train with a more generalized dataset, possibly not from Kaggle, but I understand that that would mean extra crawling effort to get the data needed with enough size. I would also recommend finding ways to measure time since post-publishing with better accuracies, and it is natural that as longer the process left, the more reactions it will gain, albeit slower over time, but this model still cannot take into account that temporal factor. The last recommendation I would make would be to explore ways to extract more parameters from posts other than the ones I did, since I believe there is still quite a lot of unexplored territory when it comes to LinkedIn post analysis. And that is it for my presentation. I hope you enjoyed. Thank you.
Okay. Okay, let me first say, go back to the slides where you pre-process your model to make it more, that about there. Okay. Now, first of all, and this is a comment, so it applies to what I said earlier. When I said earlier that you should apply your pre-processing to your in-sample only, that's because that kind of pre-processing, the standardization, depends on parametric value like the mean or standard deviation. In this case, because your pre-processing is purely functional, like taking the square root, taking the cube root or whatever, or exponential, there's no parametric dependency. So in this case, you can apply across the board. Okay, this kind of functional thing is doable from in sample to out sample. You don't have to say, I do this. There isn't a parametric calculation like in sample mean, in sample standard deviation. So you're doing correct. This is quite correct. Having said that, what you're doing now is a lot of, let's say, hand-tuned feature engineering. Okay, feature engineering is quite, and I would call it a dark art. A lot of data scientists rely on that extensively. A lot of them spend their days and nights trying to do feature engineering. On the whole, I don't totally subscribe to that school. I think some simple data feature engineering does make sense. Obviously, things like if you are predicting return, then you don't want to use the price, you want to take the log of the price, something like that. That would make sense. Moving average, things like that to smoothen out the time series data, that would make sense. So I think in your case, I would assume that this is motivated by something beyond just trying to make it look normal. I would assume, I kind of guess. I'm not quite sure what individual values are, HSP, FLW, AM. Give me an example. What does CWC stand for?
Content word count. So I just count words and content. And CMF is
AMF?
content meaningful word frequency. So the meaningful words in the content text body. So basically, I tokenize words, I remove the stop words, so to, from, I remove that,
Okay, gotcha.
and then meaningful words.
And what's HSP stand for?
Hour spent. So basically, when posts are posted, that there are time that they spend before being observed. So basically, 2 days ago, 3 weeks ago.
Okay. Now, so that comment about pre-processing, I guess, benefits everyone. Now let's go to a little bit to your specific to your thing. There are two things I want to say. First of all, technology has gone, has developed leaps and bounds in the past 2 or 3 years with respect to natural language processing. I think what you're doing is excellent. What it is that you do some kind of pre-processed feature. Okay, so all these 1, 2, 3, 4, 5, 6 number, these are kind of like statistical feature that is abstracted from the LinkedIn post. And then you're trying to make a prediction based on this. And then you go to a traditional prediction model. So that would make sense. That would make sense. Having said that, there's a lot more in terms of NLP, understanding the semantics of the meaning of the, you know what I mean? All this word embedding. So this would have been something that you needed to do because you were working based on summarized statistics, right? There's a paragraph and then you have summarizing statistics. There's 6 of them and you're trying to make prediction based on that. And that it's the right way to do. It's the right thing to do. If there isn't other technology set. Right now, especially if you're working in English, there is a whole technology stack that has to do with trying to interpret the semantics. So it's not like counting the number of meaningful words, but actually getting to the sentiment, okay? So I think this is a very good exercise, but as a professional application, you have to realize that the NLP world has gone, much deeper. You're not working on the summarizing statistics anymore. Second point, and this is something that I think you might have a little bit of misunderstanding. You don't need to do gradient descent on linear regression, right?
Oh, yes, but
Gradient descent is like a generic all-purpose tool to minimize error, okay? So if you throw me a machine learning algorithm, you throw me a data set, and you provide me with a loop to evaluate error, okay? I can use this, feed into gradient descent as a generic tool to try to minimize the error, okay? Now, with linear regression, actually, you don't need to do that. Linear regression only has one minimum, okay? Linear regression only has one minimum. The model itself only has one minimum. So that's why when you go to a linear regression software and you say, find the coefficient of linear regression, it doesn't run gradient descent. It actually plugs in the sum of square formula. You see? Remember, I don't know, just look at my hands. Let's say this is an error surface, right? Generically, there's a lot of, lots of false bottom, and there's a lot of bottom here and there. And you use gradient descent, in particular stochastic gradient descent, so that hopefully you get to the bottom. But with linear regression, it's like a bowl. It's like a well-defined bowl. So you can actually define the right bottom for that bowl. So you get that in one shot. You don't use gradient descent necessarily. Okay. Now, there are some regression kind of functions that are quote unquote called regression, but it's technically solved with gradient descent. There might be. I think maybe like Gaussian process regression. I think that one, don't hold my word to it. I may be wrong, but I think like Gaussian process regression, it's called regression, but it's actually a generalized machine learning model. So when you solve that, you use gradient descent. I think, okay? I might be wrong here. But definitely multiple linear regression is just matrix multiplication. There's no gradient descent, okay? So I think you're using the wrong tool there. That could be. But I think I like this. I like what you're trying to work around. So this is exactly what we would have had to do when we didn't have all this, BERT transformation model of semantics. 5-6 years ago, if I were to do like a text analysis of LinkedIn, this would have been, very important. Having said that, things like meaningful word count, that also relies on more recent technology. Of which words are meaningful, which words you have to pay attention to or something. But things like tokenization, counting the, excluding the connecting words, something like that. I think that's been done for a while. So I think it's a good exercise. It's good exercise, okay? I'm not sure how much of an upshot this has. I would imagine if you were dedicated to doing LinkedIn analysis, you will probably benefit more from a more in-depth semantic level understanding. Okay, more
keep that in mind.
Yeah. And I think there are natural language processing tools for that nowadays that you can play with. Okay, but very good.
Yep, thank you.
Okay, Nicola. Nitsha. Are you here, Nitsha?
สวัส
Okay.
ดีค่ะ แอนดิชารัตนาอัมพลนะคะ
Parkinson's disease is
Can you hear my
progressive
video?
nervous system disorder that affects movement.
I can hear it,
Symptoms
but
are
it's a little.
tremors, slow
Yes.
movement, rigid muscle, and speech changes. Parkinson's disease cannot be cured and no definitive laboratory test to diagnose. And that leads to my project. Parkinson's disease is a progressive nervous system disorder that affects movement. Some symptoms are tremors, slow movement, rigid muscle, and speech changes. Parkinson's disease cannot be cured and no definitive laboratory test to diagnose. And that leads to my project, Parkinson's disease detection, and I am Nisharatana Ampon. My objective is to accurately diagnose Parkinson's disease by voice recording and to find factors that attribute to the diagnosis most. Now, here's my map. Since my analysis is classification, so I use supervised learning. This data is from UCI website, and you can check up this website below. This data set is composed of a range of biomedical voice measurements from 31 people, and 23 of them are Parkinson's disease patients. Here is the sample data. My methodology consists of 4 steps. First, data observation. Second, statistical properties, pre-processing, and the last one, model building and evaluation. In my data set, there are 195 rows, and 147 of them are Parkinson's disease patients. My columns, there are 24 of them: a name column, a status column, and a voice measures. Here are the list of the columns. For the white column are the voice measurement test. I did some checking the duplicates value, the missing values, and also removing the name column. For the statistical property, this is my heat map, and this shows the correlation between each attributes. For the blue one, the dark blue one means that there's high correlation, and the white one, such as this line, mean low or least correlation. Here are some pair plot and skewness. For the pre-processing, since my data is biased, so I have to use the scaler, and I use min-max scaler between -1 and 1. And for the splitting, 10 test splitting, I'm splitting the ratio of 80 for train and 20 for test. And here's some my example of X train. In this model building, I will use logistic regression, decision tree, XGBoost, and random forest. In each model, I will train the model, predict, finding the accuracy, confusion metric, classification report, and find the AUC ROC. For example, for each method, I will do something like this. For the conclusion for AUC and ROC, we can clearly see that XGBoost and random forest has the highest area under the curve, which is 0.86, comparing to logistic regression and decision tree, which are lower than that. So this is the table of conclusion. Apparently, it came out that random forest and XGBoost have the same conclusion. For example, for the accuracy, they both got 95%, recall of the model 100%, precision is 94, F1 score 97, and the ROC AUC is 86. Next is feature importance. Considering random forest and XGBoost, they both got MDP full and PPE in the top 3 of the graph, which means that MDP full and PPE are the most feature important to both random forest and XGBoost. Even though Parkinson's disease can't be cured and no definitive laboratory test to diagnose, this project could play a significant role to be effective screening step prior to the appointment with the clinician, and this might significantly improve the symptoms by using the XGBoost and random forest model. For the future improve, this could give the basic idea of the Parkinson's disease detection application by using MDVP full and PPE, which are most important features to our model. Thank you.
Okay, Cup. Do me a favor, please calculate. Not calculate. If you can re-record the videos, I think the background screenshot is not clear at all. I couldn't see the number or the figure or the text. It's a little bit hard to read. So you might want to do the recording again. Also, it's quite soft. Everyone, Cup. Quickly, let me just draw your attention to this before I forget. Yeah, when you upload your video to the YouTube, okay, use this title, correct? Basai dash Big Data Analytics Autumn Project dash. By the way, on this thing, for some reason, I think you should group yourself 3 number dash 5 number dash 2, like not all 8 numbers together, and not 3, 3, and 4. I think it should be 3, 5, and 2. If you can do that, that'd be great, because I can do search by different cohort as well. Okay, so it would be something like 6, 3, 5 dash, and then 5 numbers here, and then dash 2 numbers. Okay, just rename your thing, but other than that, it's pretty good. Okay, just that. Okay. Right, now back to your paper, okay? Back to your paper. I did already say that you should maybe re-record it a little bit, okay? The ROC looks a little bit interesting. Normally, what you would get is a bit more like a jacket per data point. Now, I understand that you only have like a 200 data points, but it's still a little bit suspicious that you get a complete straight line to the top, and you know what I mean? Make sure that your code is correct. It does look a little bit suspicious. Your data is, by the way, is quite interesting. Normally, when you have medical data, when you have credit risk data, when you have any kind of binary classification data, the feature class of interest is usually a small minority. For example, in a banking application, you have 1,000 applications, maybe only like 0.5% or maybe 10% or maybe 5% is a bad debt, right? So the positive case tend to be a small minority. It tends to be imbalanced that way. Where yours is kind of interesting. You only have like a normal control case of healthy people is about 1/3. So it's quite interesting. I've not seen that a lot in practice. in practice, the positive case, in this case, disease, tend to be a small minority, okay? The best case will be 50-50, but if anything, it will be imbalanced by having normal people without disease being the majority. But in your case, the majority is Parkinson. So maybe this data is collected from a specialist clinic that treats Parkinson, so that the people who are measured, people who have all this data from, are people who are referred from other clinics. You see what I mean? Like when old people go to a general doctor, a GP, a GP or a general medicine, they think that this person has Parkinson, already make the screening, preliminary screening, and then send it to this clinic. And then this clinic gathers the data of 200 people. That's why you have only a third being normal or healthy individual. So it's quite interesting, right? So do that, and I like the idea of comparing. There's one slide where you do feature importance, and you do feature importance across different methods. Okay. Now this is a luxury that you have, not other model have. In some application, let's say you try 5 different methods. This one is useful, this one is accurate, the rest is all crap. So you have to throw everything away, right? This is all good. This is the only good one. And like I told you, in most cases, if you have 2 of them, say this one is also good, this one is also good, I would go for the one that's easier to explain, right? So if neural network has good performance, decision tree has good performance, I would tend to keep the one that has good performance and easy to explain. Okay. In this case, you have 2 of them that are sort of like similar. So what you might want to do is actually cross-reference them, cross-check them. You know, do they agree? First of all, you did this thing very good. I like that very much. Confirming that for both models, this variable is equally important. Okay. So the ranking in terms of feature importance is the same in agreement. You can actually even do more than that. You can literally look at the prediction. Okay, so there's like a prediction of positive case, right? You can say how many of them agree, right? How many of them are in disagreement, right? And in the future, if they are both equally good, roughly equally good, and roughly just as easy to explain as the other, so what you might want to do is just keep them both, or keep them, you know, keep 3 of them. In which case, there might be some kind of ensemble model learning, right? So in other words, if this one say, yes, Parkinson, this one say, yes, Parkinson, you can say, well, let's have them vote. If they both agree, this is even more strongly predicted, right? You can do that as well. So this is a general case of what's called ensemble learning. You can have something like, let's say we have model A, B, C, D, E, you can create literally another linear regression model that has, or logistic regression model that has coefficient that weights A, B, C, D, right? So that becomes a further work you can do. Now the reason I said it's a luxury you have that other models don't have is because you have, I think if I heard you right, a few of them that have similar model performance. Okay, but if one is a clear winner, then certainly you have to get rid of the others, right? So I'm not quite sure if I understood you right, but I think my sense was you have at least 2 models that are equally accurate. I think one being XGBoost or something, and the other one I think random forest. I'm not quite sure. Okay. Now both XGBoost and random forest are similar in that they're based on more than 1 trees. Okay, so that's good. So do a little bit of checking on your ROC. I think that's a little bit suspicious looking. Usually it's a little bit, you know, by each data point, correct, not correct, but it's not a straight line and then like this for all of them. Okay. Okay. You only get something like this for like a perfect model where you get everybody correct and then and so forth, right? So if you have a few of them that they have different ROC, but they all have this flat line going up, I think that looks a little bit, just check your work a little bit, okay, just to be sure. Okay, Good.
thank you ค่ะ
Very good ครับ Okay.
Okay. Passive.
That's it. Okay, good.
Passive.
That's it. That's it.
That's me. I'll share my screen.
Oh, sorry, I missed. Sure.
Uh,
Okay, share screen. Good.
I, one second. You see my screen?
Okay ครับ
Okay, ครับ Sorry, Muhatib, and I'll be presenting my big data project. So first, let's start with the introduction. So this project is an analysis project of an NBA player, which my main objective is to find out about the influence on the court. So for the stat that I will be using to determine the influence on the court is usage rate, which is a percentage of the team play that a player was involved during the time they were on the court. So the problems and the questions that I want to know from this analysis is what kind of player is the most influential. So basically, there's more playing time in more influential position. Which position is the most influential? What kind of play is the most influential? Does age matter? Does player with more versatility have more influence on the court? And does play style matters or relate with influence? So next, let's talk about the analysis method. So the main program I use is Mathematica, and the function I use are functions like list, plot, and fit to predict the line of best fit and correlation. Next, let's take a look at the data set. So this is what my data sets looks like. It contains of 592 roles, which are 590 players, and the columns consists of 28, which means there are 28 categories in total. This is my mind map. So since my project is mostly visualization, the main thing on my mind map is just visualizing and basic mathematic function. So first, let's start with minutes per game. As we can see from the graph, that the more minutes players have played, the higher the usage rate gets from the line of best fit. However, we can also see that there are some players who play less minutes but produce a high usage rate. This means that minutes, while minutes does matter, it is not the most thing that is the most related to usage rate, because some players can do it while having less minutes. Next, let's take a look at position. So from this graph, red line represents center, blue line representing guards, and green line representing forwards. So from this graph, we can see that the more minutes players played in each positions, guards tend to produce more usage rate. From this analysis, guard is the most influential positions on the court according to the graph. Next, play style. So scorer and passer, players who average higher points per game, as we can see on the top graph, tends to have a higher usage rate. And play on the bottom graph, you can see from assists per game, player who pass a lot during the game tends to also have a higher usage rate as well, but not as high as when compared to scoring. Next, let's take a look at versatility. For versatility, we can see that the more versatile the player gets, the usage rate gets higher. But however, we can also see that there are some players which have a very low versatility, but still produce a high usage rate percentage. This means that players who are only good at one particular stats can also be can also have a high influence on the court. Now, next, let's take a look at our correlation matrix. And from this correlation matrix, we'll mainly focus on the usage rate. So as we can see, the stats that has the most correlation with the usage rate is points per game. from this we can see green is high correlation and orange is low. So stats like age or and offensive rating and defensive rating per game, that kind doesn't really matter. So with this, this is a summary of my analysis. So according to the graph, the most influential position is guard, and versatile player tends to have a high influence in the game. However, being good at individual stats can also lead to high influence. The stats that can also have a high influence in particular is scoring, and according to the correlation, the stat matrix correlation matrix, stats that are mostly related to influence in the game is points per game, following by versatile index, assists per game, minutes per game, and rebounds per game is the least correlated to the usage rate. So while players play style and age doesn't have any relation to the influence in the game. So to my summary, if you're looking for a player who has a high influence in the game, you should probably look for a guard who's versatile and can score a lot of points. Thank you.
Okay, go back to your I guess scatter plot a little bit. How are you drawing the lines? For example, you have the 3 colors line, one for guards, one for go back to that slide a little bit.
One sec. You mean like the scatter plot with like 3 lines?
Yeah.
Okay. This one?
Right. So where did those lines come from?
You mean like originally? So it comes from the linear regression of the scatter plot.
No, linear regression. Linear means line, right? Straight line. This is not
Right.
a linear regression.
Oh, linear regression is x and x square, right? I use x cube, but like I used to. So in linear regression, you use a linear method fit. But for me, I use linear method fit, but like use a cubic function instead, because
Right.
like in the beginning.
Okay, so you have kernel fit, right? With linear, with square, and cubic, right?
Right.
Okay, so you should say that. Be a little bit more precise about that. Now, to be honest with you, when you have data that looks a little bit like this, you have to agree that there's a lot more noise there than there is signal, right? In other words, the variability that is explained, if you did like an R square, now when R square comes from linear regression, but even if you have non-linear regression, you can also compute R square, okay? You will find that for all cases, for all the green and the red and the blue, the R square would be quite low, okay? Would be quite low. So you have to be honest about this and just report it in your write-up as well, that even though you try your best to fit a cubic function to it, there's a lot more noise to it. In other words, you can't really explain y as a function of x because there's a lot of variability that is not explained by the regression fit. Okay, so if you calculate the R square for each line, you will find that it's very low. You'll find that it's very low. Okay, so which is okay. I mean, it's just the data that you are dealt with. So you're not able to explain y as a function of just x. Now, I think it's a little bit more work. If you were to try to get a real prediction, you have to incorporate other input. So it's not just one x, right? Go to another graph. Okay. Y as a function of something else.
This one?
Yeah, exactly. See, so you can see that in your problem, it's actually multivariate regression that you're looking at. Okay. And if you're talking about multivariate regression, and each dimension you have a cubic function. You can imagine that this can get really complicated real quick. This to me suggests that instead of sticking with nonlinear kernel, it might be better off to just throw in other kind of machine learning algorithm, decision tree, random forest, XGBoost, multi-layer perceptron. That would make more sense because individually, what this tells you is that you can't really predict Y from any individual variable. Okay, and so if you can think of it this way, you can think of multi-layer perceptron as inputting a vector input and allowing a lot of nonlinearity. So you don't have to individually build in a cubic regression for x1 and then cubic regression for x2 and then cubic regression for x3. Individually, they would not work. Okay, so I think you would probably have to regress y as a function of vector x simultaneously. Only then would it get some kind of result. So confirm my suspicion by calculating r squared for each of this plot. You will see that it's going to be a very small number. Okay, but that's fine. I mean, you are going to be judged based on the quality of your analysis. Now, if your analysis, you did it right, and there's a lot of noise, there's a lot of randomness, and you don't get high R squared, that's not necessarily your fault. It may be that the data is noisy. Okay, you just have to prove that. You just have to show that. Okay, Kap?
Oh, I have questions, Kap. So like, so what you're saying is try to find like another method that show a better result.
I think so, because this is not giving you this is all it's saying right now is that if you try to fit a cubic regression on individual factor, okay, I can't read what each individual one is. I'll just call them x1, x2, x3. If you fit y as a function of cubic function of x1, y is a cubic function of x2, y is a cubic function of x3 separately, none of them will give you anything close to a usable R square. Okay? There's a lot more variability in Y that is not explained by the line. Okay, so I would imagine that what you should do is to have multivariate model, right? A lot of you have this top, I don't know what the axis, I can't read, the top one, the bottom one, and the previous one, and all that. Just throw that in. Okay, you might get a more decent prediction in terms of root mean square error. Because you don't have the numbers here, but I would imagine the root mean square error would be quite poor. The R square would be quite poor for each of this plot. Visualize it, just from looking at it, you can tell, right? So try work on the middle part a little bit. I think the data set is interesting, and work on the middle part of the methodology a bit more. I think you'll be surprised. There's some predictability when you put them all together. Okay. Okay, Kap.
It's me ใช่ไหมครับ yes, it's you.
Kirut, okay, Kap.
Just a moment. Can you see the screen ครับ is it loading? Wait for a second.
Started sharing, but not yet.
Okay.
Okay, you're on, Kap.
Just a moment.
Hello, my name is Stuart Limatibun, and I'll be talking about my
I think you have problem with the connection a little bit.
Yes, the thing won't load. Can you give
Yeah,
me
you can play the video that you record. You don't have to play from
Okay.
YouTube.
and just a moment.
Shall we come back? Oh,
Yeah. Wait, I got it.
by the way, if you want to shorten the name of this class, it should be data analytics, not big data, because we focus on the analysis of data, not really on the big data part.
Hello, my name is Lim Matibun, and I'll be talking about my final project. So in this PowerPoint, there'll be four main topics. I mean, the introduction, problem, hypothesis, and analysis. The introduction will be about my project and about the data that I use. The problems are, what are the problems that I want to solve? And third, my hypothesis. So what's my hypothesis for the future? And from the hypothesis, what is the best possible outcome? And fourth, my analysis method, what method I use and the reason why I use them. So to introduce about my data. So my data is all the application in Windows Store. So the main objective that I use this data is to allow future developer to know the trend of popular application throughout the whole time. The data which I use is the data collected from the Windows Store, and the data, and I'll be showing this data through visualizing them. So there are three main problems. First, the problem is that I want to know, that I want to solve, is how much application been put throughout the years. Second, the type of category of application that is most popular that have been out from 2010 to 2021. Lastly, the difference between paid and free applications. So is there any relation or in each category between a paid and a free application? How much is the difference? My hypothesis, there are three hypotheses. First, free application are more likely to be top application in Windows Store. Second, games are more popular in Windows Store. Third, as the year goes by, companies start to publish more application throughout the year. So I use three analysis method. First is the bar chart, second is line chart, and third is clustered column. Here's my mind map. So the first method is the bar chart. So as you can see, from 2010 to 2021, there's been a significant increase by a lot throughout the years. The reason why I use bar chart is because it's easier for users to see that there's a more demand of application as the years go by, meaning that there'll be more competitor. By having more competitor, they will need to make their application more unique and more useful to solve the problem. This also have another meaning. It means that there's probably more problem that people are facing, so they're downloading more applications. The second method is the line chart. As you can see, the most category that people download are action and adventure, and there's a significant difference in each of them. The reason why I use this is because developer in the future, they can see the trend of what people are most interested in, so that they can or they can see where is the market in this industry that they can attack. Lastly is the clustered column. As you can see, there are three main topics. There's free, included already in the software, and paid. As you can see, the action and adventure, which was the most published, have most free and paid. And there's a significant difference between top application, which is free, compared to paid. And you can see that most of the application that is famous are mostly free or included. The reason why I use this method is because it can help people see whether they should make their application paid or free. And it's a easy way to differentiate the difference. For example, there's some application that have very few paid types, and they're more famous in the free ones. Thank you.
Yeah, I think you started pretty strong in the sense that you have 3 hypotheses you wanted to test. And I like that, that's being precise. But then the analysis, it's not giving something that convinces me statistically or visually, right? First of all, if you're going to make the whole analysis based on visualization, you have to make sure your visualization really gets your point across. Having a bar chart of 40 different game types, that's not really, I can't see anything. Okay, and you're confounding 2 things. One is the type of games, and one is whether or not it's it's free or fee based or whatever, premium based. And you can do, you can certainly do statistical tests whether or not the free software of a particular genre or a particular type is performing better, right? So by saying, you're confounding 3 things. If a game is more popular because of the category, or it's more popular because it's free, but there's also the fact that certain type of games, certain type of applications tend to be free. So you're confounding these 3 things. So I'm not even sure that from analyzing correlation alone, this answer that. Okay, so I think the focus on the hypothesis was very nice, but then afterward, when you went to the analysis, I don't think it backs up. So it needs quite a bit of work. I'm not quite sure how I can make suggestions in a short space of time, but I think you need, compared to your friends, for example, who've done a lot of method in terms of making the prediction, in terms of making the cluster analysis. I'm not quite sure what is being proved. Okay, it hasn't quite proven anything to me yet. Okay, but keep at it and spend a bit more effort on it, see what happens. Okay, Kap, good luck, Kap.
Thank you.
So next is Siwarat. Okay, she's joining us. Hello, Siwarat, are you ready?
Yes,ค่ะ.
Okay, cool.
Frequent item set. Can you hear the sound,ค่ะ?
Loud and clear.
Frequent item set. First, we will start with the objective of the project. Since 2020, sales of the company started to drop as an effect of COVID, and many companies boosted their presence through online marketing and promotions. Therefore, if we can use the information to find the association between the trend between items frequently bought together to find the possible promotional and marketing strategies for the company, it would be beneficial and practical. Next, data set. This data set is a general ledger of a company showing the sales. The source is from my family business. The numbers used in this project comes from column 2 and column 22, which are the customers and the items. These numbers are nominal scale. Each ID represents an item or a company. There are 211,503 rows and 33 columns of data. The distribution of the item frequency is skewed right, which means the mean value is larger than the median. And in this case, it means that there are many items that are not frequently bought together. Moving on to the methodology. This is the reference to the mind map. This shows a part from the mind map that covers the scope of the project, covering machine learning, supervised learning, data mining, and frequent items. Next is the code. This part is the extraction of the customer data from the file, and below it is the number of total customers, which is 9,177. This is the extraction of the item data from the file. Below is the number of total items, which is 2,941 items. And below that is the frequency of each item descending. After extracting the data, I use the function transpose to pair the customers and the products together by the rows they are in. Then with these functions, I changed the pair into associations. Now I put the items that are bought by the same customers together into a basket, which the basket is the key of the association, the ID of the customer. And the items in the basket are the values of the association. Because in this project, I am finding the most frequently bought items, I pick only items that have a frequency over 500. Then from the histogram, we can see that only 5 items have a frequency over 1,500. Therefore, I choose to focus on those 5 items. Then from the 5 items, I use the function sequence count to count all the times that the combinations are together. However, the sequence count function counts only when the items are in the exact order. But in the basket I created, the items are not always in the same order. Therefore, I have to create this grid to show all the counts of all combination sequences. This chart is a summary of the outcome received from the program. From the result, the combination with the most frequency has the frequency with 1,631, and the following with a frequency of 973. Therefore, a possible promotional strategy is to offer a bundle promotion for said combinations online. And a possible marketing strategy is when only one product from the combination is added to the cart, have an algorithm that suggests the other product as well.
Okay, top, very good. In general, like I said, I did write a little mathematical script just to show you how you would do item set analysis. But as I mentioned in class, if you were to do this professionally, chances are, I think what's called a priori algorithm that's encoded, I think in Python, I think that one is more comprehensive in the sense that, you know, once you've done that, it throws out automatically bunch of analysis like support or something like that, or conditional probability. But I think that's good. It's very important that you also realize that my basket items are not sequence dependent. So that if you do just sequence count, you know, buying toothbrush before toothpaste is not the same thing as buying toothpaste before the toothbrush. Okay, but in your case, it's actually the same thing. Try to work on the visualization a little bit. Maybe you can work with not just 2 items but triplet as well, right? And so you can milk a lot more information than just any finding 2 pair of things. Okay, so I think you can do more. You can do more with this. You can certainly do more with it, especially since it's your own business, right? You probably want a lot more insight. So which items appears. You know, you can even do your own hypothesis that is not a standard item set analysis. For example, if somebody is going to buy more than 3 items, what's the likelihood that this person will buy this thing? So you can imagine that this thing is one of those things where it doesn't appear a lot by itself, it doesn't appear in pair, but if you buy 5 items, chances are it's in there, or something like that. You know, you can make all kinds of interesting hypotheses that is unique to your business. Okay, after all, we have no idea what item XYZ is, but you do. And some of them may have more high value than the other, some of them have higher profit margin. So you can cross all this information with maybe profit margin, right? So you have, you know, from our point of view, I have no idea what they are. I just know that these two appears well together. But from your point of view, these two that appear well together, one of them has a very low profit margin, one has a high profit margin. Certainly you can put that in the analysis. Now you in the paper, you don't have to reveal what that is, right? Because it might be a company secret that you're not, I don't know what you sell, okay? So it may be something, you just say item ABC, that's fine. You don't have to tell what it is, but you can say this item is very interesting. It doesn't pair well with the other, but it always appears whenever people buy more than 5 or whatever, okay? So you can throw in all kind of hypotheses. Item set analysis is a very crude sort of like intersection and union and intersection analysis. So the interesting part comes from your hypothesis, okay? So you're not restricted to just a standard question like which pair appears best, okay? Good, okay,ครับ
Thank you ค่ะ
Okay,ครับ, next.
Next, Jiranat. Jiranat. Are you here? Okay, cool.
Okay, can you see my screen?
Not yet. Maybe you have to click share screen first. Okay.
Okay.
Hi, so before we start, I want to mention about the objective of this project. The goal is to find the insight of the business to optimize sales while also enhance the customer experience. This project will be covering 2 sections, the customer segmentation based on their behavior using RFM method, and checking the performance of the product using SKU categories and products. Well, the first thing I did is I used the data list plot function to plot throughout the year in order to understand how this business is doing. From the plot, it showed that the highest of the total sale amount the store can make is no more than 8,000, and this pattern repeats throughout the year. For the mind map, this is the reference mind map I used for the project, mapping all the descriptions and methods. The data is I downloaded in tabular format, both in descriptive and quantitative. And in this project, I use unsupervised learning machine, mainly the cluster analysis. And here's the data set I'm using. I download the data from Kaggle, and I use the semantic import to import all the data in the form that is easy to use. So for these slides, I want to quickly go through our F&M values. For R is how recent a customer made a purchase. To calculate recency, we'll be taking 1 day after the last invoice date of our data as the snapshot date. The date different will give us how recent the last transaction was made. From the distribution down here, there are a lot of transactions happening in recent days, which can be implied that there are a lot of new customers or it is a festive occasion. For F is how frequent a customer purchases. If we look at the chart, we can tell that the store has little number of repeated customers because the majority of the customers only purchase less than 4 times a year. For M is how much the customer spent. For this one, we can play a lot around with it. For example, I use the reward sort to find the top 10 potential customers based on the total sales amount. The store can apply this to see which customer they should be focusing on, and they can also do the opposite to find the distracting customers, which I will be mentioning later in the slides. After that, I did the correlation metric to compare each value together. For each correlation, I did the list plot and the k-mean. For the list plot, we'll be able to see a very general trend, while for the k-mean, we'll be able to group each into k-section. Next step I did was to calculate RFM score. Basically, is to divide RF and M into a specific range, give them a score for each range, and then stick the score back together. So there are 4 steps in calculating RFM score. The first step is to extract the data in a specific form in order to sort customer based on recency, frequency, and monetary values. Secondly, you will need to create a data set that join these 3 values together respectively. Then you'll need to find the range of each from the beginning date to the ending. After I got the score, I put them into histograms. The results show that
the store rarely have the big spender and the repeat customers, but they have a lot of new customers. The adaptation on another project I'm working on is RFM scores allow store to have a deep understanding about each customer behavior. For example, if I look at the highest RFM score, I will find the ideal customer who usually visit the store and spend the most, allowing me to be able to suggest the right promotion or enhance the customized marketing content to maintain a good relationship. Moreover, we can do segmentation. On the left, you'll see 12 bar, which come from 4 points from our F&M score in combined. Then we can divide them into segment. The lesser the score, the less potential the customer are for the stores. The insight I get from this chart is that the store has to improve because there is a lot of distract customers and a lot of customers are still in the promising stage, which from the research I found is not the ideal stage for any store. To summarize, segmentation using RFM method will allow business to better suggest the course of action tailored to the need of each segment, while also evaluating the current strategies. I also did the SKU analysis from a total of around 5,000 products. The insight I look for is the performance of the products, the best selling, worst selling, and I also did go deeper into SKU categories to see which product is the best selling. The store can get benefit from this by applying it to stock prediction, which they can be very specific about which product performed the best during which time period of the year and plan their stock.
Okay, I think you have to at least in your report, spend at least one paragraph on what you mean by market segmentation. I think you're not that clear on the concept yet. Okay, market segmentation. Okay, what does it mean? Okay, well, certainly it means you segment your customer, right? Segment customer. Okay, now. What do you segment with respect to? Okay, you can think of three groups of data. Okay, one group of data is about who they are, right? And that's when you think about demographics and whatnot, right? In which case your segmentation would be like combination of demographic factors like old male, young female, right? You notice that, right? So segmentation tends to be about combination of attributes. Okay, so you're not going to segment things like old versus young. That's a very naive way of doing segmentation, right? Old people, young people, boy, girl. Okay, that's very naive, single dimension segmentation. Chances are, if you're looking to analyze your customer, you would find this kind of combination of factors like old male, young female, or something like that. You see what I mean? Okay, this is very simplistic, but the point I'm trying to get across is that segmentation tend to be more complex than that just looking at a single attribute and say high or low, male or female, right or left. Okay, now if you look at behavior again, okay, if you look at behavior, whether or not it's RFM, now you probably would not want to say, well, is this a high R or low R? Is this a high F or low F? High M or low M, right? So likewise, your segmentation would be maybe based on variability, like high R but low M, or high M but low R, whatever. Okay, so this is where unsupervised clustering comes in very much. Okay, so I would imagine that it would be, instead of just making a histogram and scatter plot of the pair, this is an example that's right for doing unsupervised clustering. Right? Okay, and on top of that, there is also two different clustering you can do. You can do clustering with respect to just RFM alone, or you can do clustering with respect to RFM and other attributes. Okay, so in the end, maybe there's a high cluster of all male, high frequency, low M. I don't know. Okay. So this is something, these are intricate patterns that you can uncover. Okay. RFM, you have to understand, it's a very crude way of calculating reward points, basically. Okay. You like high R, you like high F, you like high M. Ideally, it's high everywhere, which is not going to happen. It's not going to happen, right? So in terms of segmentation, you have to realize it's not about getting high in everything. Okay, that's not segmentation. That's just your wish. You wish your client comes in a lot, okay? Comes in a lot and comes in recently and spend a lot every time. That's just your wishful thinking. It's not segmentation. Segmentation is about taking combination of attributes and behavior and value added into account, right? So have more intricate thinking about how the multiple attributes come together and how you can use unsupervised learning to cluster them. Okay, then it would make sense that maybe you can identify 3 major types of clients. Okay, again, the silly example I gave you was if you find out that all male, frequently but low value, whatever. Okay, then you start to build narrative on that. But just to say, who's high, who's IR, who's IF, who's high M, that's a little bit too crude. That's sort of like before you have data analytics class, you should be able to do that even before you came into this class. Okay, so add more. I hate to use this word, but add more sophistication to your analysis. Okay, but okay. Other than that, okay, that's good. It's good. Well motivated. Okay, Kap.
Thank you.
Next.
Hi,ค่ะ
Okay, Kap, and this would be Radha, right?
Yes.
Okay, Radha. Okay, Kap. Good. Okay. Go.
You can't hear the sound, right?
Kap, go.
คือผมเพิ่งเห็นมีทีเนี้ยนะผมเพิ่งเห็นมีตอนจ้าอาร์ตเนี่ยตอนอาร์ตปุ๊บเห็นเลยเดิมก็เห็นเป็นเอ็มอยู่แต่พออาร์ตมันก็มีใช่เป็นคือเอ็มมันคือช่องว่างของเอ็มกับ Y ครับ
Today I will be presenting my big data project on market basket analysis. So first, let's start with the introduction. Market basket analysis is a very interesting tool that can be beneficial for retail stores to analyze the purchasing pattern of their customers in order to adapt their strategy and increase their sales. The objective of this project is to use data mining, which IBM defines as the process of uncovering patterns and other valuable information from large datasets, together with unsupervised learning, to perform market basket analysis on data from an online retail store in 2010 in order to suggest marketing strategy for the store. And I have chosen this topic because I am interested in the field of business and marketing. So first, let's take a look at the dataset. This dataset came from the website Kaggle. It is a transnational dataset which contains all the transactions occurring between the 1st of December 2010 to the 9th of December 2011 for a UK-based and registered non-store online retail. The company mainly sells unique all-occasion gifts, and most of their customers are wholesalers. It consists of 541,909 rows and 8 columns. As this data is extremely large and due to limitations on my laptop, I have chosen to analyze the data in December 2010, which consists of 42,481 rows. Now let's take a closer look at each attributes for the columns. So first we have invoice number, a nominal data uniquely assigned to each transactions. There's stock code, a nominal data uniquely assigned to each distinct product. There's description, a descriptive or categorical data that gives the description of each product. There's quantity, a numerical data that shows the number each product was purchased. There's invoice date, which shows the date and time in which the purchase were made. there's unit price, a numerical data that signifies the unit price of each product. There's customer ID, a nominal data uniquely assigned to each customer. And lastly, there's country, a nominal data that provides the name of the country where each customer resides. So now let's take a look at the methodology. So to perform this market basket analysis, I have used Mathematica as the main tool to perform the analysis and to run the code in order to do all the data mining and unsupervised learning. Mathematica helped me to conceptualize purchased products into baskets and then analyze them according to the occurrence of the most popular item in comparison with other products. And this helped me to find which product is most commonly bought and to find the most common combination of items bought in order to adapt the store strategy to increase their sales. So now let's take a look at the code. So I first started by importing the data. Then I do the histogram of the time to see the pattern, and you can see that it peaks around here of 2 to 3 p.m. After that, I rank all the items to see which items are the most frequently bought and also create a histogram of it. So from here you can see that white hanging heart tea light holder is the most popular one with 241 occurrence. So after knowing this, I want to know which items is most frequently bought with tea light holder. So you can see here that knitted Union flag hot water bottle is most commonly bought with the most popular item tea light holder. Now let's take a look at the most important part of the code. Here is the matrix of the top 50 most popular items in the store. So from this matrix, you can see the occurrence of different combinations of item. And in this matrix, the most popular combination is a combination between items 3 and item 10, which has the occurrence of 87 times. And these two items are Paper Chain Kit 50s Christmas and Paper Chain Kit Vintage Christmas. Now let's take a look at the result from that. So this, we can have 5 results in conclusion. First, most order happens between 10 a.m. to 3 p.m. and peaks around 2 to 3 p.m. Second, the most frequently bought items are white hanging heart tea light holder, Regency cake stand 3-tier, and Paper Chain Kit 50s Christmas. Third, the white hanging heart tea light holder is frequently bought with knitted Union flag hot water bottle. Fourth, the most common combination of items is Paper Chain Kit 50s Christmas and Paper Chain Kit Vintage Christmas, which has 87 occurrence. And the last one is other common combinations such as these two have 75 occurrence and these two have 70 occurrence, which is also considered as high occurrence. So what does this imply for the store? First, they should be most ready to boost their sales during the prime time of 2 to 3 p.m. and try to have promotion, advertisement, or flash sale to increase sales in other time. Next, they need to make sure they have the stock of the 3 most popular items as they are most frequently bought. And the store can also spread these popular items to mix in with other products to increase the exposure and visibility of other products. They can even also have the pop-up menu to ask customers during the checkout if they also want to buy these products, as it is likely that the customers will buy. And lastly, for those common combinations of items, the store can bundle those products together to increase the chance of the customers buying 2 products and just 1. And this can help increase the store's total revenue. And this is all from my project. Thank you.
Basket analysis. Didn't realize that so many of you are into it. Okay, right. I think to be honest, the data that you have actually gives more than what you can do with this basket analysis, because it's got a time of day and whatnot. With basket analysis, I think it's a very thin set of analytics. It doesn't really tell you much. Okay, so I think what you did was a very good job in terms of presentation. Milking out the conclusion, make it like you're discovering a lot of insight from the data. But having said that, again, basket analysis is a very thin framework for analyzing. You can only do so much, right? So I think presentation was very good in trying to come up with the narratives. In terms of application, it could be that could be. I just want to make one point, by the way, that normally the way it's used, if you find two items that are already pair well together, they don't try to promote that. Remember, I told you this is being cynical. If you find two items that pair well, they would actually put them far apart. Remember in the grocery store that I mentioned, if you buy milk and eggs together, they'll put milk at one end of the store and egg at the other, so you walk through and buy some other things. So I think what exploitative way of thinking, which is what marketing people try to do, is to say, well, these two already pair well, so we don't need to promote them. We'll promote them in combination of something else, right? So maybe you can have a high value, high margin product. This data set, I don't think it gives individual margin. Otherwise, it would be quite interesting if it gives a product margin as well. So you can say that, okay, this pair well, but can we make it a triplet? So you pair this with something that's not popular. I don't know, okay? So it's very hard to make market basket analysis interesting. Okay, I think you did a very good job of trying to sell that. So that's good. Okay, Kap, very good. Next.
Hello.
Hi. Okay.
Okay, I think I shared my screen.
And this would be Kai Kap. This should be Jean, right?
Yes, can you hear
Kap,
the video?
Okay, Kap, go ahead, Kap.
I think we cannot hear you video, but I can hear your
sorry.
voice.
Am I supposed to share the sound or not mute myself?
You shouldn't mute yourself.
Oh, I see. Okay.
I think maybe you have to share your sound too. Can you?
Oh, okay. Share sound. So, hello everyone. This is my big data analytics project, and I will be doing about education and education effectiveness. My content will be covering 5 different parts. So project scope, data set, methodology, application findings, and future implications. First of all, I want to start with a quote from World Bank, where education is a very, very important factor. And we can see this from the SDG goals, that a lot of the pressing issue in the modern society can be counted to high school education. Education course is split into 2 different parts. So literacy and numeracy, which we will be focusing on numeracy because of the data set that we have. For the problem statement, Thailand has been under a lot of scrutiny in terms of its education system. And so it's predicted to fall behind neighboring countries. And this can be seen in the TMR report from UNESCO and PISA, where it showed that Thailand has or doesn't reach minimum proficiency level for mathematics, and there's been no improvement of test performance from 2003 to 2015. And so by taking student performances, we hope to find the contributing factor to high school education and aid schools' resource management for higher education effectiveness, which we will operationalize as test performance. And the reason for this is because Thailand uses an accountability system based on test scores, which, as mentioned earlier, there has been no improvement at all. So this is a mind map, and my data is a tabular data that includes attributes from all the scale measurement level. We're gonna do a model, classification model, that is done using neural network to classify performance. And we will be borrowing a lot of the decision tree, random forest, and regression analysis models from study papers to kind of reference our own model. For the objective, as mentioned earlier, we want to find the most significant attributes and also create a classification model. Data set, the data set is based in Portugal, from high schools in Portugal, and there's 396 students, 33 attributes, and also the term 1, term 2, and final grade, which will be very, very important. As you can see, there's a lot more attributes, which we won't go over every single one, but it can be split into 3 different categories. So there's profile in student, academic performances specifically, profile in school, and profile in family. I would like to draw your attention to these 3 attributes, which is very important. So G1, G2 is term 1, term 2 grade, which gives a numerical score of 0 to 20. And G3 will be very important because this will be the output for the classification model, and G3 is basically the final grade. Methodology, we're going to use supervised approach. So binary classification specifically, where we classify G3 as pass or fail. Based on G3 being less than equal to 10 will be fail, and more than 10 will be a passing grade. And then this will be done using neural network. Before we get into the model, I'd like to say that I borrowed a lot of the inspiration for the model is based on a descriptive model provided by a study by Paulo Cortes and Ali Silva on the exact same data set. So they kind of identify the most significant or the relative importance of each of the attributes. Data preparation, I imported data from a .csv file into Mathematica. And so I set up the header, transpose the data using the dataset functions. I set up the training and test data, so 300 training data that will be used for neural network. I encoded the attributes so that it could be fed into the neural network. So this is a visualization for the classification of binary classification specifically for the G3. So for the models, before we go into the specific performances, I just want to go through that. The model is a neural network that uses catenate layer, linear layer, and then for the output layer uses logistic sigmoid. So as mentioned, the most significant attributes is term 1 and term 2 performance, and this is not just based on studies, but also specific kind of descriptive model of this data set. So as you can see, by taking into account both term 1 and term 2 grade, the error rate is only at 6.25% to predict pass or fail. So we tried with 1 term performance, and it showed that a shorter interval could have a stronger predictive performance. So as you can see, the term 2 performance, or taking into account term 2 performance without term 1, has lower error rate compared to only term 1 performance. So we wanted to try without previous term performance at all. And so as you can see, the error rate is not great, but it's still at around 32.5%. Tried different model with different attributes. So the error rate is still below 40%. As for the application, by inputting a set of attributes, the model can actually classify whether that set of attributes will fall into the category of failing or passing their mathematics exam, and also give out the probability. And the application of this is that it could be used to reference school predicted grade to reduce bias, and also identify students who might need support before the final exam. The key finding here is that G1 and G2 is very significant, and this can be seen in the error rate that is very low. So there is a very strong positive correlation between G1, G2 and the performance of final grade. And this collaborates with a study by Oscar Van Bogle, where he basically proved that quiz to final performance prediction model is actually very effective to rely the prediction model on quizzes throughout the term. And so it implies that a regular course assessment throughout the year would aid students in their final exam performance. Based on descriptive model, despite not as significant attributes such as attendance and academic school support could be very important. So these things need to be in place to set up an environment that could really support students. Future implications and limitations. So we could try different classification models such as the Erasmus grade conversion that would produce a model that maybe could be more applicable to the education system we are using. For example, 10-level classification could specifically apply to the British curriculum system. We could compare with different models such as random forest decision tree. As for limitations, generalizability is a key issue here because the data set is based in Portugal. Not all attributes were tested as well because of time constraint. And also we operationalize education effectiveness as exam performance, but exam performance is not the only indicator for educational effectiveness. These are the references, and thank you for listening.
Okay, I think this is one of, 3 presentations I have seen so far that even reference other work. So this is very good. In the report, you would actually follow the reference with the author name and the title, right? Not just the URL link. Okay.
Yep.
Okay, good. Very good. So this is very interesting. Let me get this comment right away out right away, which is that using G1 and G2 to predict G3 is self-fulfilling a little bit. So I don't think that in itself is something you should spend a lot of time on, even though it does give you a lot of predictive performance. The more interesting thing is the one where you have other factors. You don't have G1 and G2, and you get error of 32%. Now, even though the error is higher, it's a little bit more interesting to me. Okay, again, you know, you don't need neural network to tell you that if you perform well in G1 and G2, you're going to do well in G3. Okay, now what might be interesting in this case is the following. If since you're using neural network, you can do like a SHAP plot or SHAP analysis of variable input, and then you can say that for even if you put in G1 and G2 performance, you can have some other variable that is important. Then in practice, you can say that for people who are doing well in G1 and G2, what distinguishes them between those that continue to do well in G3 or the final performance versus those that fell apart at the last minute, right? So your analysis becomes a little bit of an early warning. It's not that, if you're not doing well in G1 and G2, you're not likely to do well in G3. No, it's about saying that even if you did well in G1 and G2, what are the factors that makes this person likely to fall behind when it comes to G3? Is there something else that is important when you take into account G1 and G2? You see what I mean? So I think the two interesting thing would be, like I said, the analysis without G1 and G2, and the analysis of the factor importance of other things, even if you have G1 and G2 into the model. Okay, so having G1, G2 and get good prediction, 90% accurate, that doesn't excite me, because that seems a little bit self-fulfilling. Okay, so that's good. And I like the fact that you went on to find the net encoder, because you want to make the input right. Now, another thing I'm not quite sure is, why would you, is the performance is an ordinal number. In fact, I think it's a ratio scale. Why would you force to make it a pass fail, right? If you have a G3 as a performance number, I think it would make better sense that this is a regression problem, not classification problem, right? And you even hinted at this, because instead of having pass fail, you have, say, a five grade system or whatever you were hinting at the end. That's even more reason to not use it classification, right? Classification is cat versus dog versus elephant, right? Classification is not for low versus medium versus high, because low, medium versus high, that is clearly ordinal, right? And I think in your case, if it's actual score, actual performance, it's actually the most informative of them all, meaning it is actually a ratio scale variable. So if your target is a ratio scale variable, why would you do classification? Why wouldn't you do regression, right? So I think you making your problem less interesting than it could be, right? Because what's more interesting, being able to predict the grade or being able to say, is this person going to have G final grade greater than 10? That's less information, right? So you didn't need to do that. You didn't need to do that because your data is richer, right? So you by making your problem a classification problem, you make your objective, the objective of your analysis, less interesting than your data allows. Your data actually allows more precise prediction, right? So I would try regression, but I think you've done the coding groundwork. So doing that shouldn't be too hard. Okay, shouldn't be too hard. Okay, so I don't see any reason why you start with a perfectly good ratio scale target. You should make it a binary classification. Okay.
Actually, that was the plan at first, but because of the time constraint, I couldn't get the regression in. Yeah, but but that was the plan as well.
Yeah. So do get that in. That would make it really interesting. Okay. And in your write-up, you write a little bit about the lack of data. So you have this motivation for Thailand, but in the end, you have to use Portugal student or something like that. Okay, that's fine. So that would also indicate, it would be a message as well in your paper that we should have this kind of data set for Thai student. Why not? That sort of thing. Okay, but you're making finally, when you make the reference about the previous analysis on variable importance, are you comparing your analysis of variable importance with that finding, or are you using that finding to select your variable? Be very sure. You can do both, okay? In other words, you can say this study placed importance on A, B, and C. Therefore, you use A, B, and C as your variable. You can do that, okay? I don't like that. I would prefer something like you do your own experiment, A, B, C, D, E, and F, and see whether or not the variable importance that you found agree with the previous work. That's more interesting. But you can do both.
Can I ask super quick question? For finding the relative importance by myself, if I use logistic sigmoid for each of the attributes to get
easier, yes.
That's okay, right?
Yeah, that's
so
fine.
I can basically link that to the neural network model as well.
No, you can't. You can't say variable importance. Variable importance is specific to the methodology. Okay. So yes, if you want to spend a lot, in my opinion, if you're getting decent regression, logistic regression result, you don't need to use neural network. Okay. So in view of the fact that the previous work is logistic regression, and you're trying to find variable importance, and with variable importance, you can do this coefficient, right? From logistic regression. I might try that. Forget about it. And in fact, like I told you, this is not a classification problem. So it doesn't even have to be logistic regression. It could just be simple regression, right? Okay. Now, be very careful. You can only use linear regression and find variable importance if your inputs are scaled, right? If your inputs are not scaled, then you can't compare the coefficient. Okay. So I think I sent the link explaining that. Finally, let me iterate the fact that yes, you can use variable importance for logistic regression or linear regression. You can't say that this will be the same thing as variable importance in neural network. Okay, because neural network picks up a lot more intricate information set. So it may be that some variable is so important in a non-linear way that a linear model doesn't pick up. Okay, so variable importance is not universal. It's not universal. Okay, for a linear model, it may be. So if Let me give you an example. If you have a support vector machine that does not have a nonlinear kernel, and you have a logistic regression problem, chances are they will agree. Okay, so logistic regression and support vector machine would probably, my understanding is they will probably agree on variable importance. But once you throw it in highly nonlinear model like neural network, I don't think it's guaranteed. Chances are it would be different. Okay?
I see.
Okay. Same with decision tree. Okay. If you try variable importance with decision tree, variable importance with linear regression, they probably will be very different. Well, it doesn't have to be. It doesn't have to be. It just depends on data, but it's potentially different. Okay. So because again, variable importance depends on the combination of your data set and the method.
Okay.
Good, Cup. Very good.
Thank you, Cup.
Excellent. Okay, Tanyanan, Cup, you're up.
Let me share my screen. With inevitably high can you hear the sound? Okay. Competition in the retail industry nowadays, knowing your customers' buying pattern can give retailer a competitive edge. With the use of association rule, the retailer can find hidden associations between product items and draw inferences on how presence of one product may affect another. However, the customer buying pattern may vary throughout the year. As you can see from the changing number on this bar chart, showing the sale of 20 different products in 4 periods. This variability can be assessed by finding overall variability of association rule, which is the variability index of how support, confidence, and lift ratio of the association rule changes in each period. Referring to the mind map, association rule is an unsupervised machine learning technique, and OCVR value is calculated from standard deviation and mean value. With this problem and knowledge in mind, this project aims to find the following insight from data of one supermarket. First, identify the overall customer buying pattern using association rule mining. And second, identify whether the association rule in each period is vulnerable to changes using the overall variability of association rule or OCVR value. The data set used in this project is a data set from Kaggle, recording all of the transactions of one supermarket over the period of around 2 years. It consists of 3 columns and around 38,000 rows. The first column represents the customer ID, the second column represents the date of purchase, and the third column represents product purchase. Referring back to the mind map, the data is all descriptive and categorical data with customer ID, product, and date as nominal scale. This is the research process flowchart. The first step is pre-processing, which includes grouping data from the same transaction together, delete duplicate items in the same transaction, and convert transaction date into period. For this project, the dates are categorized into 4 periods, which correspond to each quarter of the year. And this is how the data set looks like after pre-processing. The next step is to find the overall association rule. First, find frequent item set that passes minimum threshold of support. Then use those frequent item set to create association rule. After that, find association rule that passes minimum threshold of confidence. And lastly, find the lift of each association rule. The parameter setting for support and confidence is done by trial and error to find the best value for this data set. The last step is to find the OCVR value. We first start by finding the association rule for each period. Then we find the association rule that always appear in every period. And we calculate CVC, which is index variability confidence, CVL, which is index variability lift, to find the OCVR value for those rules. These are the functions that I have defined to help calculate the support, confidence, lift, and OCVR value. From analyzing the overall customer buying pattern over a period of 2 years, I have found a total of 97 rules that have a lift value more than 1, which means that there is a high association between the presence of one product to another. For the first rule, which is semi-finished bread to whole milk, 0.16% of the transaction from all data contains both products in the same basket, which is represented by the support value. If a customer buys semi-finished bread, then the probability of customer also buying whole milk is 17.6%, which is represented by the confidence value. Also, this rule is valid as we can see from the lift value greater than 1. The graph displays all the rules generated, where the horizontal axis is confidence, the vertical axis is support, and the color shading is lift. It shows that the lifts are scattered all over, but the majority of high lift rule occur at the low support and low confidence. However, this could be because the majority of the rule is clustered around there. From analyzing the customer's buying pattern in each period over 2 years, there are 4 rules that always appear in each period. Then after calculating the OCVR values, one of the rules is very vulnerable to change as the OCVR value is greater than 30. I have also created an interactive program using the manipulate function. The users can select the period in a year they want to see, where period 0 represents the overall association rule over the 2 years. The user can then select the product they want to see the association rule in that period. From this finding, it can be concluded that the association rules were quite different in each period. From further analysis, there are only 3 rules that always appear in each period and that are not vulnerable to changes, which are suitable for supermarkets to use these to make marketing strategy throughout the year. However, for each period, the supermarket should consider the rules that are prominent in that period.
Okay, very good. Yeah, you introduced also the OCVR, which was not a statistic. I did not mention that in class, but that's good. Okay, and you make also the interactive tools that allows, you know, say end user to pick any 2 products and see what happens. Okay, so that's also very good. And the fact that there's a little bit of a, I don't know, it's a trade-off between support and lift. That tends to be something that you might find as well in practice. So you can think of something that has in a different setting. You can have something like it's very small occurrence, so low support. But once you buy one thing, it's very likely you're going to buy the other thing, right? Like let's say this is a silly example, okay? But something like if you buy fork, it's very likely you're going to buy spoon. But they're both very rare. But they you need them together or something like that. So there's a natural narrative that you can build into this kind of statistics. So all these statistics, just like in binary classification, there's a story associated with precision. There's a story associated with recall. You have a story associated with support, with lift, with conditional probability, and all that kind of stuff. So very good. And I like the print slides where you actually highlight individual. So that's a good way of doing slides. Okay. Again, present PowerPoint is good because it allows you to hold the audience captive to just one screen. So use that to your advantage. Just guide them through the logic, guide them through the narrative. So that's good. Okay, we're down to the one more person who is Sunacha. I think that's it, right?
ค่ะ สวัสดีค่ะ
Okay, hello Sunacha.
last one ค่ะ
Okay, so I'll be super tough on this one.
Okay, let me share the screen. Hello everyone, today I'm going to present my data analytics and my topic is customer segmentation. Let's begin with problem statement. The problem that I found out is that mall owners don't know much about the customer inside, so they normally face the problem of converge and gain customer to the mall. My objectives are improving the mall business by using analyzing, knowing the difference between this data set, and implement this data to marketing strategy and plan. However, tools and methods that I use are visualization method in order to understand more by graph, as well as supervised learning method under k-mean clustering in order to classify the data into groups. Now we are in the working process, which are divided into 3 steps. First, find the data set. Second, Analyze the data by visualization. And lastly, use the cluster analysis method and show the result. For step 1, dataset. This dataset came from Kaggle. There are 200 rows and 5 columns, including customer ID, gender, age, annually income, and spending score. As I have mentioned, the data is about more customer segmentation data, and it's created only for the learning purpose of customer segmentation concept. Moving on to step 2, which is about the coding. I decided to use Python instead of Mathematica, and I begin with import all related libraries such as NumPy, Pandas, Matplotlib, Seaborn, and K-means. Then import the data into code system. After that, I try to check the amount of value, rows, and columns, as well as is there any missing value in the dataset, which the result is no. So let's begin with visualization. Visualization 1, represent the gender. The bar chart shows that the customer are female more than male from this dataset. Visualization 2, it shows the distribution of age data, and the highest value is mentioned on the red box. The distribution are the same in visualization 3 and 4, which is about annually income in $1,000 units and spending score respectively. Moreover, spending score are in range from 1 to 100. If the value is close to 100, it means that the person spending so much. Last step, clustering analysis method and result. Before creating the cluster, I'm going to talk about WCSS, or within cluster sum of square. It is a measure of variabilities of observation within each cluster. In general, a cluster that has a small sum of square is more impact than a cluster that have a larger sum of square. The first cluster is the data between annual income and spending score. Start with selecting dataset and input WCSS in order to find the distance of each data point and centroid of those clusters. Then plot elbow graph to find how many clusters do we need. It normally from 1 to 10 clusters. In this example, the graph represents 5 clusters. Now we add all the value for plotting the cluster. Here's the result of clustering graph. It divided into 5 clusters as we calculated earlier. Understandable that the customer have less income, tend to less spending like in blue cluster, as well as opposite side. However, there are also half the customer that have inversely income and spending behavior. Moving on to another dataset, it is between the age and the spending score. All the coding are quite similar to the one before, but the number of clusters changed into 4 as is shown in the elbow graph. It is because the number of clusters depends on each dataset. The results show the relationship between age and spending score as we expected. The advantages from all the results are that it can improve the business profit by knowing customer insight, as well as good for planning marketing strategies. This is the extra data and result. It's only shown the comparison based on gender. I convert the string to number so it be able to plot the graph. To conclude, this is the overall method, tools, and data from making this final term project. Thank you.
Okay, Kap. This looks very good, but I just want to make sure that you don't misunderstand something. When you do cluster analysis, okay, the motivation of doing unsupervised cluster analysis is that you have high dimension description of your data, right? So even though you can plot 2 of them at a time, right? You are not going to be doing cluster analysis based on 2 dimensions. You see what I mean? So you do the cluster analysis based on 10 dimension, Then when you visualize, you are only able to visualize 2 dimensions at a time. Fine. But the point is you're not trying to do cluster analysis based on just 2 dimensions each. You see what I mean? So I think you misunderstood the reason why we want to do cluster analysis. If I'm understanding you right, I think you have like say 10 attributes. You take 2 of them at a time and you do cluster analysis. 2 more, no, you would actually do cluster analysis based on 10 dimensions. You see what I mean? Because if you are only going to do the cluster analysis based on 2 dimensions, you don't need to. You can just plot it and just look at it using your eyes to do the cluster analysis, right? That's the whole point. That's the reason why you do all this thing about, you know, standardizing so that they have the same variability, right? With respect to all dimensions, and do the cluster analysis. Then if you want to visualize, you can only visualize 2 dimensions at a time. That's fine. Then you use the color to represent cluster member and then, you know, plot them in each 2 dimensions. Or you can also do what's called dimensionality reduction, which is to reduce the 10 dimensions to 2 and then plot them, artificial dimension. But what you don't want to do is perform cluster analysis for each pair of variables. Okay, you don't need to do that. You don't need to do that. You already are visualizing 82 pair. That's the beginning. That's before you do the cluster analysis. You see what I mean? Yeah. So I think you have to redo your experiment, but it's going to show something similar to what you got, which is, you know, some kind of elbow plot and all that. That's all fine. But the purpose of doing cluster analysis is that you have more than 2 dimensions. Okay, you have more than 2 dimensions to do the closeness. Cluster analysis is about closeness, right? If you have 2 dimensions, you can see how close they are, right? The point is you can't see how close they are in 10 dimensions. That's where cluster analysis comes in, right? How close they are in 10 dimensions. Yeah. So you have to redo, I think, your work, but you have all the coding and all that already in the background. That's fine. Okay. By the way, it's called NumPy, not NumPy. From Pi to Python. There's comment I forgot to mention. Somebody recently used the word dummy variable for ID of customer. That's not dummy variable. Dummy variable is something for yes or no. Now, customer ID is not used at all, so it's not even a dummy variable. I forgot to mention that. I think I just thought of it. But other than that, okay. So you have to do your work again. Okay. So not chat, but you got your coding, so it's okay. It's not too much work. But you have to understand that the point of cluster analysis is not to take any pair of number and just do cluster analysis. You don't need to do that.
So I need to get all the dimension to.
Yes. You have all the 10 dimensions. In this case, you would standardize, right? All of them, standardize or scale them by mean and standard deviation. Now you don't have in sample, out sample, because in this case, you're literally trying to cluster the whole data set. So there's no prediction, there's no in sample, out sample break. So you just standardize all the 10 dimensions, okay? And do the cluster analysis. Now, when you plot them, you can plot them in the original unscaled value if you like. That would be even nicer, okay? That'd be nicer, but you don't. That's not that important, okay? The point is you scale it so that one variable does not dominate the other.
But at the first, I talk about the objectives that I want to do. So is it I have to redo all of it?
Well, your objective is to find customer segmentation, right? Is to understand your customer.
Yes, to understand customer.
So the idea is that you can, if your customer comes to you with 2 dimensions, okay? Amount of money and sex, boy or girl. Then you can just scatter plot that, right? And you don't need, and you understand your customer because you don't have 2 dimensions.
Oh.
The objective here is that your customer have more than just sex, age, education, income. You have 10 variables, and you can't visualize how many clusters there are in 10 dimensions. That's where the algorithm of k-means, whatever that you use, comes into play, right? To identify how they cluster in high dimension. Okay. None of this is necessary if you only have 2 dimensions at a time, right?
Okay.
Because, because 2 people can be close together in this 2 dimension, but far apart in the other 2 dimension. How would you know that? Right? You wouldn't know that. So you want to cluster your client with all the dimensions you've got. Okay? You see what I mean? Now, occasionally you would do this. You would separate the group of variables. Say this group of variable has to do with demographic. You do cluster analysis one time. Then there's a behavior with respect to spending, you know, RFM and whatnot, and you can do cluster analysis again. And then you can see whether or not the same cluster here mapped to another cluster there, something more intricate. Yeah, you can do multiple cluster analysis if you're going to do something more sophisticated. But at the first thing, the first result from cluster analysis is to do cluster analysis on all your attributes together first. Okay, right? Yeah, I mean, in my project, yes, I have done multiple cluster analysis, but not because I want to do them 2 at a time. No, that's not it. That's not it. Okay. Okay.
Thank you.
Okay, but you got the codes already, so it's not too much of a work. But you definitely have to redo the analysis. Okay. Okay, Kap, good luck. So that's it.
I have a little bit of like questions about like clarification.
Sure.
So,
what's your project?
My project was the NBA player influence analysis, the one that you suggest to change methodology.
Yeah. Okay. Yeah. I think you were looking at one variable at a time. Okay. Yeah.
Right. So like the purpose of like each graph, I want to show like a trend, basically like a relationship between like the influence and like each kind of play. So something like that. And like so what from your comment, what I'm in my understanding from what you have commented is to like try to use like change the function to visualize it better. Is that what you're saying? Right?
No. I think in terms of visualization, you can only visualize 2 things at the same time, right? Right? You can only visualize 2 variables, so that's fine. Visualization is not a problem. The problem is when you're trying to do the fit with the cubic function.
Right.
And it shows that definitely, you know, even if you put in quadratic, if you put in quartic, if you put in higher exponential value, if you put in to the power 5, 6, 7, you know, polynomial regression, you're still not going to get a good fit.
Right.
Okay? You're not going to get good fit from individual X. Okay, you will only likely get a better fit if you have multiple X at the same time. So it's not that you cannot visualize them. Yes, you have to visualize them 2 at a time. That's fine. But the point is, when you went through the effort of fitting the cubic, that would not make sense to do it just one variable. Okay, because there's so much variability in Y, there's really nothing in X. Okay, so visualization is okay. I'm not saying you did wrong. The point is when you fit in the cubic and you say Y is a function of X, that's when it failed, because you can see that, you know, for whatever line you fit, there's so much variability, right? And chances are, if you take into account other variable, X3, X4, X5, you will get less error. You get more of a fit, right?
So like so So okay, so this is what I'm understanding. So like add more x variable to the fit function.
To the fit function, yes. When you do
to create a better fit.
Yeah. Now it may turn out, okay, that you are really unlucky that you add x2, x3, x4, you still get a lot of noise. That's possible as well, okay? But you haven't shown that, you haven't done that, okay? So definitely univariate fitting y versus one x at a time was not sufficient. So you have to try to fit multiple x, right? Multivariate regression. Once you did that, you still might fail because the data is so noisy. That's not your fault, right? That's not your fault. It may be the data has full of noise, but you haven't proven that. You haven't shown me that you have tried multivariate fit and still get a lot of noise, okay? So the reason you get a lot of noise here is maybe because, think of it this way. If I were to get like a prediction of cancer, and all I have is height, that's not going to help much, right? All I have is weight. That's not going to help much, right? Let's say predict diabetes. But immediately, if I have height and weight, okay, and weight, I already have body mass index. That's already a better predictor of diabetes, right? But body mass index, right? Height divided by weight or something, or weight divided by weight. So one variable is no good. The other variable is no good, but two of them already makes a very good prediction. That's what I think is happening here. Okay.
So like for my x's, like it's like different categories. So like one is like age and the other is like height. If I combine those,
put them together at the same time. Yeah, don't do it separately.
Would it like would it make like less sense, or like the line would make sense, but like the analysis would be like the combination of both, like.
And that's another point. That becomes another point. It's like all else being equal, you can only analyze contribution of one factor at a time. Yes, but the first thing first, you have to get a good fit. Right now, you're not getting a good fit in terms of explanation. Yeah, you are trying to explain. Was it potential? Was it potential?
Yeah.
No.
It's influence.
Influence as a function of age. It's nice if it has a good fit. The point is, it doesn't have a good fit, right? So again, you never sacrifice performance of a good fit just so that you can explain better. Okay. Remember I told you, it's only when you get a good fit and you have a choice between a model that has 500 parameters and one that has 2 parameters. You choose the latter because it's nicer to explain. Okay. But that alone is not the driving criteria. The most important driving criteria is to get a good fit first. Okay. Yeah, it would be nice if you could explain influence by age alone. That would be lovely. But you're not getting that. You're getting a lot of noise. So the first thing first, you have to get a good fit. Okay. Then work on explanation, work on insight. Why is this person a good influencer? That does have a high influence on the game. Is it because of the height? Is it because of the age? Is it because of the position? But until you get a good prediction on why, you can't say anything.
So basically, start with all the x's and then show each and I see.
Okay, and if you do that and you can't predict at all, then it's just not predictable. Okay.
All right.
So do that first. Yeah, get the performance of the fit first. That's the most important thing in this kind of supervised learning, right? Get that first, then see if you can explain why it works. You get a good prediction on influence. Oh, I realize now that to get a good influence, it's actually not the age, but the position, whatever. That comes after. Okay? That comes after. So the most important, get the most important objective first, good fit. Okay?
All right. Last questions.
Yeah.
Do I need?
By the way, if you got somewhere to go, other people just go. Just if you have a question, hang around. But other than that, have fun. See you next week. on Excel.
Like,
Okay,ครับ
like, do I need to change the quadratic formula for the fit function, or that's fine?
Well, I think once you put in all the variable, okay, you will realize that to put in the cubic, then you have this combination, what's called combinatorial explosion. Well, if you have x1, you have x1 square, x1 cube. You have x2, x2 square, x2 cube. But what about x1 squared times x2? Right? What about x1 times x2 times x3? Now these are all cubic in order, but instead of just x1, you have x1 times x2 times x3, right? What about x1 times x cube, x3 squared? So this can explode. So I would actually not do that. I would try to use, are you using Python or Mathematica?
I'm using Mathematica.
If you're using Mathematica, the data set I saw is not that big. What you might just do is just ask it to make a prediction model, and it would try a few of them, right?
So use decision tree.
Well, because the data is quite small, I think Mathematica is just going to try all of them. Decision tree, gradient boosting, whatever, right? I would not try to use, just you would try to force a fit by using higher order. If all you have is y and x, you just have one x, right? You don't have any other x. You just have something like influence and age. That's all you've got. Then I understand why you would want to add cubic, quadratic cubic, because you don't have any other choice. But you don't have just age, you have precision, you have whatever, you have, amount of practice, salary, I don't know, okay? Just throw them all in. And Mathematica is going to try decision tree, gradient boosting, and see which one comes up with the best prediction, right? And then you can click and say which model it came up with and report that, okay? But you got an interesting data set. I mean, I would look forward to reading reading your report. Okay, so try that.
I'll try my best to make it work. I mean, it's quite challenging because, like, I don't know, sports. It's like to make prediction and analysis on each topic. It's quite like it's hard to do it with numbers, I would say.
Yeah, and that's the whole point. The whole point is that you have something that is simple if you have two dimensions. The whole idea of machine learning, I can tell you, the reason why we have all this data science, machine learning, AI, blah, 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 is because the phenomenon you're interested in, your Y, is a function of more than one variable. If your Y is a function of a single variable, none of this, you don't need to take this class. Okay, if everything you're interested in, if every y you're interested in is a function of a single x, you don't need to take any statistics course. Life is so simple. Okay, so yeah, multivariate explanation is the name of the game. Okay, so you can avoid it. That's life. Okay. Okay, good luck. And again, if you have any questions, just feed in the line. I tend not to read emails or anything, but if you send it to line, your friend would see it, your TA would see it. And okay, so I'll see you next week for exam. Okay, and
for exam, is it the same, like 3 hours? And
yeah, pretty much. Okay, so good luck, all of you. And again, everybody's entitled to redo the recording or the presentation and resubmit. Come on. Okay. Are we all good?
อาจารย์ครับผมเป็นนิสิตที่ต้องไปสอบที่คณะครับคือผมต้องติดต่อ
Okay เดี๋ยวI'll this is what พัชชน Okay, I'll line you individually later. Okay ครับ
ครับขอบคุณมากนะครับอาจารย์
Okay ครับ Good luck everyone. hang tight almost over โอเคครับสวัสดีครับ
Take care ครับ
สวัสดีครับ
สวัสดีครับ thank you
ขอบคุณค่ะสวัสดีค่ะ
เดี๋ยวไลน์น้องคนนี้เนาะ
ขอบคุณค่ะ
ค่ะสวัสดีครั
ส
บ
วัสดีครับ Happy birthday
Happy birthday to somebody เหลือเยอะโอเคค่ะ
นัก
good
แช
luck
ร์
แล้วดีลูก
see you good luck